Hello students, following question is a 2-mark question from topic of strain energy methods structural analysis, where a cantilever truss is shown and it is a pin jointed truss, it is already mentioned, and it is asked that what is the strain energy that is stored in member AB. Now first of all, let's talk about what is the expression for strain energy for pinned joints. What is the expression of strain energy for frames? So let's talk about one by one. Now here we are more concerned about pin joints because the frame that is given in this question is pin joint, but for your additional knowledge I will tell you something about frames also. Now if we talk about strain energy per unit volume of a pin joint, it is given by, not pin joint, in general per unit volume it is given by half into stress into strain. Now we know that the only force that is present in a pinned joint member or a truss is axial force. So stress can be written as P by A into strain is P by A divided by Young's modulus of elasticity if we are talking about elastic analysis. And here, as we know that whatever scope we study in our structural analysis, it deals with elastic members. So it comes out as half into P square A square upon E. Now this is strain energy per unit volume. But if we talk about member AB, if we multiply this strain energy per unit volume by volume of this member AB, we'll get the expression for strain energy, and its volume is given by cross sectional area multiplied by length. So half into P square upon A square E into L gives expression for strain energy as half into P square L upon AE, where P is axial force that is present in the member under consideration. Now here in this case, if we analyze it by method of joints and quickly jump to joint B, suppose now this is a roller type of support. If some force is acting at this point, then there is no reaction at all. Now this P is equal to 0. Now if some force is acting in this member, now since no external force is acting, no external reaction in downward direction will be able to act because of presence of roller support at point B. So even if any small axial force PAB is present, it will not be having any balancing component, and it is against the principle that summation of all forces at any joint should be equal to 0. That means the force in member AB should be equal to 0. So if we know that P is equal to 0, the strain energy in this particular member comes out to be 0. Now if we talk about pin jointed frames, in pin jointed frames, as we know, we have bending, we have axial deformations or axial stresses that results in axial stresses, and we also have torsion. But the most significant of all these three is bending. And if we talk about expression for strain energy per unit volume for bending in frame members, it is given by half into m square x upon EI, and this is also an expression per unit volume for frames. But here the concern was regarding pin joints, for which answer comes out as option D, that is 0. Thank you.